Okay, topic that we're going to discuss today is how to solve systems using matrices. And that's, of course, without a calculator. Before we get into how you actually do that solving, one piece of background information that I need you to remember or know is an augmented matrix. So here's the general form of an augmented matrix. You have the matrix that we had yesterday, just a general n by m. Oh, n by n, rather. So you have a square matrix. You augment that with another matrix. So this is an n by 1. The notation for that is like this. B being the column matrix. So we're going to be using these augmented matrices when we solve today. You all have seen that before when you've done RREF in the past. In order to solve systems, we're going to have to use elementary row operations. So when you have a matrix, there's 3 different main operations that you can do on the different rows. The first one, you are allowed to multiply a single row by a non-zero constant. So you don't have to multiply the entire matrix. You're just going to multiply a single row. You can interchange rows. And then lastly, you can add a non-zero constant multiple of one row to another. So what we are going to do today is we are going to use these elementary row operations in order to get an augmented matrix in row echelon form. Okay, when you've solved systems in the past, you likely have either used inverse matrices or you've done RREF. So RREF is reduced row echelon form. So there's two different forms. There's row echelon, and then there's reduced row echelon. And they're related, so we're going to talk about both. In order to get an augmented matrix into row echelon form, you're going to do what's called Gaussian elimination. Okay, to do Gaussian elimination, there's 3 different. Gaussian elimination is the process that gets us to row echelon form. Row echelon form has 3 main characteristics. First characteristic, if a matrix is in row echelon form, is that the first non-zero entry in any non-zero row is 1. Okay. In consecutive non-zero rows, the first entry in the lower row appears to the right of the first one in the higher row, lastly, all 0 rows are at the bottom of the matrix. If there are any. A lot of times there's not going to be any 0 rows, but in the case where there are, they have to go at the bottom of the matrix. Okay, so here's an example. I'm going to have 3 different rows. The first entry in the row needs to be a 1. So I might have 1, 5, 0. And then remember it's augmented. In the next row, if it's non-zero, the first term, which we already said has to be a 1, has to be to the right of this one. So maybe it's here. And then this is going to be some number. So maybe it's a 3. No, let's make it a 0 also. And then it's augmented. The last row is either going to have a 1 here and some number, or it's going to be all zeros. So I'm just going to make it a 0 row. Okay, so this is called row echelon form. And you used Gaussian elimination to get it. So this should seem similar to reduced row echelon. Do you all remember in reduced row echelon, RREF, you had the identity matrix here? Maybe, vaguely. So what you're going to do is once you have this row echelon form, you're just going to take one more step to get to reduced row echelon. So what you're going to do is you're going to keep going until each column has a single 1 and zeros elsewhere. Like I said, what I really mean is I want the identity matrix on the left. So an example of that. So on the left, you're going to have the identity matrix. You have zeros everywhere else. And then that's augmented with some numbers. So this is reduced row echelon form. To get here, you're going to use what's called Gauss-Jordan. It's called the Gauss-Jordan method. Okay. I think it's easiest to learn this just by doing an example. Alex?
Number 2 in Gaussian elimination, does that mean it's always one space to the right of the
Generally, yes. It's very rare that you're not going to have the 1 just to the right. The ones we're going to do, yes. Okay, ready to do an example? Can I remove this completely? Okay. System that we are going to solve is 2x add 6y add z equals 7. X add 2y subtract z equals -1. 5x add 7y subtract 4z equals 9. We are going to solve first by Gaussian elimination, and then we are also going to do the Gauss-Jordan method.
say like solve by row echelon, or are we solving by?
So like row echelon is the form that it gets to. It's not a method. Okay, so we are going to start with Gaussian. Gaussian leads us into Gauss-Jordan. First thing we're going to need is an augmented matrix. Everything is in order, but just when you're doing your homework, make sure that you are consistent in each of your equations. So if you go x, y, z, every equation needs to be in that order. So I have 2x, 6y, 1z, augmented with 7, 1, 2, negative 1, 5, 7, negative 4, 9. Okay. It is incredibly important that you organize your work. So I'm going to show you the general notation people use to organize their work. Ultimately, what we need, if we're in Gaussian, is we need 1, 1, 1, zeros here. So the first thing that I'm going to do is I have a 1 here. If I switch these two rows, then my first row is good and I don't need to do anything with it. Notation for that is R12. So what that means is you're switching rows 1 and 2. Okay, I'm going to have a big ask that you guys actually look at what I'm writing. So if I make a mistake, we catch it early, not at the end of the problem. Okay, so next thing that we're going to need. This needs to be a 0. These also need to be zeros. And then we'll get the 1s later. So what I'm going to do is I'm going to take negative 2 and multiply it by the first row. And I'm going to add that to the second row. So that'll give me a 0 here. Likewise, I'm going to take the first row and multiply by negative 5. And I'm going to add that to the third row. So first row stays the same. I have negative 2 add 2 is 0. Negative 4 add 6 is positive 2. Positive 2 add 1 is going to give me 3. Positive 2 add 7 will give me 9. Okay, negative 5 add 5 will give me 0. Negative 10 add 7 will give me negative 3. 5 add negative 4 will give me 1. And then 5 add 9 will give me 14. Okay. First row is good. Second row is almost good, except we need that to be a 1. So that's what we're going to handle next, is dealing with the second row. So I'm going to take the second row and multiply by 1/2. So I'll have 0, 1, 3 over 2, 9 over 2. And then last row stays the same. Okay, first row is good. Second row is good. Third row is the last one we need to handle. That negative 3 needs to be a 0. Any suggestions as to how I can get that to be a 0? Which row are we going to use, the first one or the second one? Second one, okay. So we're going to take the second row, we're going to multiply by 3, and we're going to add it to the third row. Okay, so we get 3 add 3 is 0. We get 9 over 2 add 1, which will be 11 over 2. We get 27 over 2 add 14, which I'll tell you is 55 over 2. Sorry, I kind of ran out of room. Okay, we're almost done. This 11 over 2 needs to be a 1. As soon as we get it to a 1, we'll be in row echelon form. So now what we're going to do is we're going to take that third row and we're going to multiply by 2 over 11. When we do, we get 0, 0, 1, and 5. Okay, so this is called row echelon form. We can solve from here. Top equation tells us x add 2y minus z equals -1. Second equation tells us y add 3 over 2z equals 9 over 2. Last row tells us that z equals 5. You got z equals 5. Plug that 5 into the second equation. You get 15 over 2. Subtract that, and you'll have -6 over 2, so our y is -3. Plug that into the top one. Is it okay if we don't write all that down? Okay, we end up with an answer of 10, -3, 5. So that's Gaussian. I also told us I want us to solve using Gauss-Jordan. Okay, we are not going to do all of that again. This matrix is still helpful, so we're just going to start with the matrix where we left off. Are there any questions on Gaussian before I keep going?
Why are you able to do all the stuff where you multiply the rows and add to each other, but still make them the same?
If you think of them in terms of equations, it makes a little more sense. It's like taking an equation, multiplying it by a constant, and adding it to a new equation. Okay. Anything else? Okay, Gauss-Jordan, we need the left side to be the identity matrix. Bottom row is good. The issues we have, that, and that all need to be zeros. So as soon as we get all those to zeros, we'll be in reduced row echelon form. Okay, so to deal with this second row, what I'm going to do is I'm going to take the third row, and I'm going to multiply it by -3 over 2, and I'm going to add it to the second row. I'm going to get rid of this 2 first, actually. I don't know that it'll matter in the long run, but that's what I'm going to do. Okay, so instead, I'm going to take the second row and multiply it by -2, and then I'm going to add it to the first row. Okay, so the second row stays the same. Third row stays the same. Okay, so I'm going to have 0 add 1 gives me 1. -2 add 2 gives me 0. -3 add 1 gives me -4. -9 add -1 gives me -10. Okay. So the reason that that was a little more convenient is I now can take care of both of these in the same step with this one. So what I'm going to do is I'm first going to take the third row and I'm going to multiply it by 4 and I'm going to add it to the first row. And then I'm going to take the third row and I'm going to multiply it by -3 over 2 and add it to the second row. In the hopes of getting, not the hopes, in the plan of getting those to be 0. So bottom row stays the same. Okay, so or 4 times the third row add the first row. So we get 0 add 1 is 1. 0 add 0 gives me 0. 4 add -4 gives me 0. 20 add -10 gives me +10. And then here, 0 add 0 gives me 0. 0 add 1 gives me 1. -3 over 2 add 3 over 2 is 0. -15 over 2 add 9 over 2 is -6 over 2, which is -3. So we get 10, -3, 5, which should not be a shock because we had already solved the problem. Okay. Questions? Is this something you have seen before? No. Okay. I really feel like you all need to do one. So, that's what we're going to do next. Do you see how it would be very easy to make a mistake? But if you have good notation, it's easier to understand what you did. Right? Like if I hadn't written out any of the work, I would have no idea where I got my numbers from. Here's the one that you all are doing. 2x, subtract 3y, add z equals 13. X, add 4y, add 2z equals 3. And then 3x, add y, subtract 3z equals negative 14. I would like you to follow the same directions as before and do Gaussian elimination and then Gauss-Jordan. I would like you to work with the person next to you so that if you make a mistake, hopefully you'll catch it. Good luck. Yes. Please try this with the person next to you, because if you take different steps and you make a mistake, you're not going to be able to find it. Or you're going to have a harder time.
If we can switch one, that make it easier. We can do this. What if we switch all of them? Can we switch them all around? Yeah. Yeah, why not? Let's switch the middle to the top. Okay, so 1 and 2. And I'm gonna switch the other one. Which one we switch? So then it'd be switching it. Now just put them in the row they belong. So then I would be switching rows. Great. So first I switched 1 and 2, and I switched. Okay, I should put it in a different order, because then it's like they become. Okay. Next, we need to get rid of the zeros on the bottom. Okay. So should we just start with the middle? There's only one here we have to go. So if you let's multiply or R1 by negative 4 and add it to R2.
Oh, I was gonna say, let's
Multiply negative 3 R1 plus R2.
could you just try to have a different
No,
brain?
it's 3R3
I didn't hear you, I'm sorry.
plus R2.
Okay,
No.
so then that will cancel.
Negative 2R2 plus 3R3.
But
I want
then I can make it negative 11, negative 6. Well, where'd you get the negative 6?
No, because I want the 1 to be
Plus negative 3.
first 1 to the top left.
Negative 9 plus that. Is that
So
negative
you multiply
3?
that negative 3 on 1.
Mental math is so
Negative 3
negative 6.
No, you're not changing the first one. I was just gonna do, I switched the first one. Now the 1 is constant.
Yeah.
So I was gonna,
I was like, wait,
yeah.
Did you do 2 6?
I was gonna do R2
Now we need to
plus
put
3R.
Oops.
so what if,
I was
Negative 0.
which one do you want to start with?
follow my first.
We actually
So
don't
I
need
just
to
in the other row. Wait, shoot,
We can just eliminate these.
isn't it negative 11?
What
Sorry,
if,
I like
I
the
tell you
one
what,
there,
I
so I
took
wanted to keep it.
2 math classes in college. This is all we did. Was matrix.
Oh shoot, you had a 1 there.
So you will use it a lot. You will
Should we change it? Or should we fix the... I think we can change it, 'cause we're not gonna touch that row anymore, right?
No, you don't care.
Let's change it. So let's do 1 over 11 times R2. Right? Yeah. Would be negative 1 over 11. Yeah. Right.
Oh, yeah. Yeah.
done that for sure, but the other ones.
13 minus
There are like a bunch of ways you can go about it.
So let us, first, should we just do row 1 times -2 and add 2 row 3 and see what happens?
Do what?
Row 1 times
Yeah.
-2.
And can I ask you what that did for you?
I got a 0.
But you also need a 0 there.
Yeah.
Did you see now that
It's hard.
if you get a 0 there, you're no longer gonna have a 0 there?
Oh my god, I'm ready.
If you use
-11
Wait, did you do that?
and -3
2 times 3 is
and
so I have to multiply.
Let's multiply row 1 7.
To check my mental math
just to get rid of it. 11.
Yeah, we got all the ones that were bad. We kind of messed up by getting them. So now let's multiply. We need to get rid of the 11. Yeah, let's get rid of the 11. Oh jeez. So not the best way to go about this. That's a big deal.
What about if you multiply by -1/11
Yeah.
and then subtract row 2? Or no,
I'm just gonna do it after. I don't know.
do what after?
I'm just gonna do 1
Oh my god, how do you split it?
Yes.
-111 row 2 plus row 3.
Did we do this in a dumb way?
But we'll get there eventually. We're almost somewhere.
You really don't have to get these ones there until the very end. Right? As long as you handle the zeros first, then you can multiply by your constant and get the
That's
ones.
where we messed up.
Oh,
Now we know. Now we know. Yeah.
So what I'm telling you is get rid of that 11.
Yeah, that's what we're.
That's what you're
Yeah.
gonna do.
Yeah.
Okay, so
R3.
or wouldn't it be -111 R3?
Yeah.
Wait. Oh, sorry. Are you saying?
I mean, just a negative, just 11 R2. I'm getting confused.
So 11 or 2.
Wouldn't it be easier, hypothetically, if we did -1/11 R3, so then we don't change the 1?
Okay.
Actually, no, that doesn't matter. It doesn't work that way.
Okay. No, Emily. We rearranged all the ones.
That's what we did. We're still going with it though. We're getting
Yeah,
there.
we're going with it.
But we
I can see where I'm going. So
we're almost there.
I know where.
Okay, wait.
11, 0, that's a 0. 11, so 9. So 9, so it's
Wait, why did we do? Is it +11?
Yeah, possible.
Okay, my bad.
So then,
So 9,
Because that would get rid of
6.
I love mathematics.
so then,
30?
yeah. So now we just do R3, 1 6 R3.
We are the smartest girls in the world.
Do you need more pages?
Okay, when you all get an answer, you know how to check it, right? To make sure that it's correct.
Calculator.
You just plug it back into the OG.
Yeah, plug it back into the equations.
Emily. Oh, God, is it giving numbers? 0, 1, 9, 3, 11, 0, 0, 1, 3.
In the middle?
Wait, the night part? What'd you last time? 5.
Uh-oh.
Wait,
1
why
6
did you
of
get
30.
Oh, we'll find it down to 15 thirds.
But that makes it positive, doesn't it?
It's okay.
Or is it positive? I wait.
So now,
X plus 4y. Yeah. Negative 20.
We made a big boo-boo.
No.
No, it's, yeah.
Yeah, negative.
What
And
was the
then
big boo-boo in there?
we rearranged all the ones and then switched
Yeah,
them.
everyone did that.
It's, I feel it's
I'm
seems
just
so
gonna
easy.
restart. I can't do this anymore.
Oh my gosh.
That's why I said do it with someone so that if you make a mistake, you find it.
X plus 6 equals 3. And that equals negative 3.
Wait, so that's just negative 2, right?
Now, we have to do this.
Isn't this negative 2? So negative 8
Yeah, okay, I
plus
did.
10
Oh, yeah, here's the equal
2
sign.
or 2. 1. X is 1.
X
I got
Yeah,
all
it's
of
equal
them.
sign.
Oh, oops. Negative 8 plus
Your
10.
values for x, y, and z are all integers, just so you know. We're not getting fractions for x, y, and z.
Because,
So y is negative 2 and z is 5, right? So let's plug them in again.
so you,
Negative 11y minus.
Okay, when you minus 8,
So it's
when you multiply
a row by a constant, and then you add it to another
Oh, yeah,
row.
wait.
Yeah.
this
That
one,
row you multiply
I got
by
one.
stay the
Okay,
same.
one.
yeah.
Why?
We got our answer.
1, negative 2, z.
Because it's just an equation.
Yeah.
Okay, time to do the other thing now.
But you could ultimately then just divide it by that same value again
So
to get back
what
to where you
should
were.
we do first? Should we fix the middle row? Get the zeros in there.
I mean, you could write out the multiplied version, but
Yeah.
essentially you're just multiplying.
Oh, this feels so wrong.
R1, so negative
to step 1.
9 over 11 R1
That was 45
plus R2.
So that's 26.
Is that it?
I feel like such a senior.
Yes.
Writing on card.
Negative 82.
The seniors give
And then
no
X.
cares.
And then we
You're
can
doing
multiply it.
technically not correct.
So negative. So
The
it's.
one Brian had.
Oh, it's negative 2. That's why. That's the right answer. I was like.
You have to have both.
Yes, but however,
It doesn't change the solving. It doesn't change the solving, but it's not.
Wait, what did we do?
Negative 9 11 R3 plus R2.
I plugged it in and it's still.
I was busy writing it.
Okay, let's just check. Okay, now we have to fix the next one.
No, no, no.
We just do it in the same steps.
So because the middle one is the middle one still a 1?
Yeah.
Oh, I'm Dumbo.
You can just do row 2 times negative 4 plus R1, and then row 3 times negative 2 plus R1, the same stuff, right? You can do it, right?
Okay, I just got negative 2.
That's right. I'm such a genius. Wait, that's what I got.
You knew about this.
You know it's not.
Oh,